What's up, everyone? Vin here, and this is the June 2025 Geometry Review, and we're going live. I apologize about the setup behind me. My computer, bad luck struck, and my computer kind of gave out on me today, so I had to use my laptop to set up with OBS. But everything else should run fine here, and I'm doing the June 2016 Regents exam. This is not the actual test. All right, I get that question every year, multiple times in the comments, but yeah, this is not the actual test. Okay, but the 2016 test was a bit tough. I feel like they definitely overcooked the Regents when they first launched it, so it should be some good questions for all of you. All right, but hello to everybody in the chat. Happy to see. Wow, we already have 123 people on, so thank you for coming on to support the live stream. So awesome. So, all right, I will, I'll help as much as I can. Okay. My goal is to just help as many of you through as possible, but just know, I know a lot of you are probably nervous. I've been reading I'm Cooked about 500 times in the last few days, but I would say the best you could do is just prepare and get some practice in. And then tomorrow, just show up and put your best math down on the paper. All right. I'm rooting for all of you. I hope you all do well. Okay. But I'm proud of you all for putting in this time and effort and caring, okay, because that's how you're going to pass. So June 2016, there is a link in the description, so you can, I can't help you with bio at Adrian. I took bio in 2002, 2003, but let me see. Do I even have that book nearby? I do have to take a bio test. Oh, here it is. So I am doing like continuing credits for education. So I have to take 4 more random tests, and I have to take it in something I've never done before. So I'll let you know how that goes. All right. Mega cooked. Yeah. Well, we'll see. Hopefully you'll get people to do a little better. All right. Yeah. All hundos all around. I hope everyone gets hundreds. All right. Question 1. So let's see what we got here. And I'm using Microsoft OneNote because once again, my Mac gave up on me a bit. Like it's still kind of working, but it's not running OBS well, which is what I use to stream. So here, a student has a rectangular postcard that he folds in half lengthwise. Okay, so here's some sort of postcard here. And they fold the rectangular postcard in half lengthwise. So this is like where the crease is when they fold it in half. And then he rotates it about the folded edge. So imagine it's spinning like this. And then what shape would be made if we spin this? This would turn into let me make that a little neater. This would turn into a cylinder. Okay, so this would turn into a cylinder. All right, let me make that art a little bit better. But they said they folded it in half lengthwise, but the only answer choice that has a cylinder is choice 3. Okay, so that's going to be the one. Okay, it could be vertical or, horizontal here. But the time that the direction matters is if like they give you something specific, like let's say they gave you like a triangle and they're like, hey, we're rotating it about this, then it's going to go this way and make a cone. All right. So that's why it's not choice 1. And, if it were to rotate about a different part here, then it would make, a different looking shape. So the rotation though have to have circular stuff. Like these two are definitely out because there's nothing like circular about those. So those are no good. All right. So choice 3. All right, question 2, a dilation. So we have a 3-inch line segment here is dilated scale factor of 6. And the center is at the midpoint of the line segment. So you have some line segment. And if you dilate this line segment here, which is 3 inches, and you dilate scale factor of 6, and this is, let's say, your center, it's going to push everything out this way and this way, but the scale factor is 6, so we just do 3 times 6 is 18. All right, one concept I want you to know, though, is that if you dilate a line, let's say you were to dilate a line like this. So if I dilated a line and my center of dilation was like, let me change colors here. So let's say my center of dilation is on the line. So like my center of dilation is here. Then it's going to push the points out, but they're all going to stay on the same line. So the line is unchanged. Okay, so when the center is on the line and the line is infinite, then the line is unchanged. Okay, but if it's a line segment, that's a different story. The line segment will expand. Okay, it expands out. I probably shouldn't have put arrows here like this, but it's going to expand out like this. Okay, so the distance from, let's say, here to here is going to get multiplied by 6. So that's how it's going to work out to 18. Some might say, wait a minute, this is 1.5. But yeah, if you do 1.5 times 6, that gives you 9. So if you have like 9 inches on either side here, and I don't know why this is erasing now. Wait, what's going on? It's like in possessed mode. Yeah, I'm using Microsoft OneNote, so it's going to take us. Oh, there we go. Maybe there was something I was writing. Okay, so this is like a 9-inch segment here. And then if I draw that a little neater, this piece here is also, 9 inches. So then 9 plus 9 is going to give us 18. So this one here is going to be choice 4. Okay, cool. All right, next one. So this one I thought was like kind of a silly question. It's like more of an algebra question than it is a geometry question, but whatever. Kevin's work for deriving the equation of a circle is shown below. So there's his work, and we got to find where he made a mistake. So first, what did he do? He distributed. That's not wrong. Minus y squared plus 20. See, the minus goes plus. But then this is where the mistake is. So you see at this step here, he's supposed to add 4 to both sides. He's completing the square in a way. Remember, like, you take the x term and you go half of the coefficient of x and then squared gives you 4. And then that's what he's adding to both sides. But you see how on this side he subtracted instead of adding. So the mistake is at step 2. Okay. I mean, after this, he factors correctly. That's x plus 2 times x plus 2. And then this makes negative y squared plus 20 minus 4. Like, he followed through with the mistake. So if this were free response, I'll say like this would get partial credit. Okay, so we could give this partial credit, if this were in the free response. But in the multiple choice, well, we're just analyzing his work. So, we could look at Kevin and be like, oh no, Kevin, poor Kevin. But yeah, otherwise he's fine. All right, cool. Question 4. And what button did I press? Yeah, I'm on this. I hope this Windows laptop holds up. It only has like 16 gigabytes of memory, so I hope it could survive. All right, yeah, 2016. Which transformation of OA would result in an image that's parallel? So that means it has to be facing like the same direction. So same direction. All right, well, let's go through and see. A translation 2 units down should do it. If we just slide this segment down like this, see how if we just bring it down 2, it's going to stay parallel. So I just know right away it's that one. Now, why not the others? If you reflect over the x-axis, so you can see here, if like I have OA is like this, and I reflect over the x-axis, it's going to go this way, which is not parallel to this. They're going to intersect at the origin. So no to this. Reflecting over the y-axis, so if we go over the y-axis, then we would have this instead. And kind of make like an absolute value, which would once again intersect at 0, 0, so not parallel. And then rotating 90 degrees would also not be good, because if I go like, let's say here, and I make my 90 degree angle, I'm still going to cross at the origin, and these are not facing the same direction. Okay, so this one's out. That's definitely choice 1. Cool. All right. So moving on to the next one. Oh, the 1/2 AB sine C for the unique triangle will be a question for the short response. Yeah, I posted a video not so long ago on the sample items. So if you all go to my my videos, my recent ones, my most recent video was like a 4th grade practice test. But before that, I did the sample questions. So yes, that one there's a decent chance of getting, because I feel like they wouldn't release sample items if they didn't expect you all to do at least one of them. Okay, so don't be surprised if that one shows up. All right, so moving on, question 5. This is the, maybe I should put a sign on. This is the 2016 Regents. June 2016. Okay. All right, cool. So, whoops, I zoomed in. See, this thing is like a little possessed. I don't know why it's like doing this stuff on its own. So hang on, view, zoom out. Oh no, I zoomed in again. Hang on, I'll fix this. Okay. Are we good? All right, now we're good. Okay, back to, let me try one more. Zooming. Oh yeah, that's too much. Okay, this is fine. Just thinking out loud because I want to make sure everyone could actually see this. All right, so question 5. So we'll take a look. Using the information given below, which set of triangles cannot be proven similar? Okay, so these can be proven similar because if you look 9/12, so this is for choice 1. 9/12 is equal to 3/4. But that's not enough. That's only like a pair of sides are proportional to another pair of sides. The giveaway here, though, is this. So the 90-degree angle between them, like angle B is congruent to angle S, and 9/12 equals 3/4. So I could say, therefore, 3 dots means therefore. And this is true because like all right angles are congruent. So if I had to use like, the free response language, I would say this angle is congruent to this one because all right angles congruent and the sides are in proportion. Therefore, triangle ABC is similar to triangle RST by the side angle side similarity theorem. Okay, so if I had to be like really fancy in the free response, I would write all that. So which set cannot be proven similar? So it's not this. All right, now this one is, these two are similar by angle. See, they have like 2 pairs of congruent angles, so it's not this one. Now this one is the culprit because 16/32, well, even this, like these are not proportional. Like 16/32 is a half and 2/8 is a fourth. But even so, this is like such a bad word I can't even say it. All right, this is like angle side, which is not a similarity theorem. So this one would be it. Okay, and then here we look side angle side similarity theorem. Okay, so that's why this one's out. So definitely choice 3. Cool. All right. Awesome. So moving on. All right. So the next, I don't know why this thing is like, it's freaking out a little bit. So I appreciate people being patient with me as I get through this. All right. Yeah, once again, my normal computer kind of gave out on me this morning, which was a bit of a letdown. So I'm using a laptop, which I just hope survives the live stream because it uses a lot of memory. Okay. So cool. Next one. A company is creating an object from a wooden cube. So let's draw a cube. So there's the cube. Okay, wait, I can make that better. Okay, so here's the wooden cube. The edge length is 8.5 centimeters. And a right circular cone with a diameter of 8 and an altitude of 8 will be cut out of the cube. So you might be able to imagine here like the cone is going to kind of go like into, like they're like drilling it out. And which expression represents the volume of remaining wood? Okay, well, notice they all start 8.5 to the third. And that's because the volume of a rectangular prism is length times width times height. The volume of a cone is 1/3 pi r squared h. So here what we could do is we could say, all right, 8.5 times 8.5 times 8.5, because it's a cube, all the sides are the same. So we just go 8.5 to the third. But then we are subtracting out the volume of the cone, which these two answer choices, see you later, because they don't have volume of a cone. This is the volume of a cylinder. Volume of a cylinder is pi r squared h. So it's missing the 1/3. But minus 1/3 pi. Now we have to be careful here. The diameter of the cone is 8, which means the radius is 4. See how radius here they use 8 by mistake? So this one's out. It's got to be choice 4. So 1/3 pi radius squared times the height of the cone is going to be 8. Okay. Algebra 2 will be in 2 weeks. June 24 is the actual Regents, so the night before. But I have it on my channel. If you look at my live stream, like I have it scheduled. Those are the next 2 I have scheduled. All right. Awesome. So next, if two right triangles must be congruent if. All right. So two right triangles. So I'm going to draw them out. So all we know right now is that they're right triangles. So they have two right angles. An acute angle in each triangle is congruent. Not necessarily, because what I could do is I could draw one right triangle to be similar, and like see how like they could have a pair of congruent acute angles, but this one's like really big. So note of this. The length of the hypotenuses are equal. Well, that's not enough because right now, like, you know how there's hypotenuse leg? So if they just have the same hypotenuse, that's not necessarily the same right triangle. Like I could draw, something where, like, let's say I angle it like this and the hypotenuse is the same like that. But you see how these are like not the same right triangle? So this is not it. The corresponding legs are congruent. That would be it. Because if the corresponding legs are congruent, so let's say, I just get rid of this stuff here and I say like these are the same and then these are the same, then the two triangles would be the same by SAS because the right angle is between the two legs. Area equal is not enough because I could have like, one half, my base and height could be like, let's say 3 times 6. And then my other one could be like 1/2, like 9 times 2. So I could have like a 9 by 2 right triangle, and I could also have like a 3 by 6 right triangle. And then these would have the same exact area, but they're not the same. So, because the product of their legs are equal. All right. Awesome. So, moving on. Oh, wow. 350 of you have joined the live stream. Thank you to anyone just coming on. And if you haven't subscribed yet and you find this review to be helpful, I would appreciate, if you would press the subscribe button. And I have videos for geometry. I have videos for Algebra 2, pre-calculus, AP calculus, university calculus. I do live streams for all the regions, and I do them for the AP calculus exam. All right. What sequence of transformations will map triangle ABC onto triangle A prime, B prime, C prime? So looking at this, what I like to do for these questions is see like, all right, B has to match with B prime. I'll change colors here. We also need A to go to A prime. And we'll do one more. So I'll just get this one to highlight. We need point C to go to point C prime. So I think we could see like the triangle has to turn. It has to rotate. See, like the red has to line up with the red, the green has to line up with the green, and the purple has to line up with the purple. So it definitely has to rotate. And then the triangle has to grow, so there needs to be a dilation. So here, these are out because reflection, translation, these are only rigid motions if I use the vocab. So we need the triangle to change size. And a rigid motion preserves distance and angle measure. So reflection, translation, rotation, reflection is not going to help. But here, the reason why it's rotate and dilate or dilate and rotate is because the triangle has to turn in order to land on the other one. If we just dilate and translate, we're going to, like, this thing's going to grow, but then it's not going to be facing the same direction as the triangle A prime, B prime, C prime. So we wouldn't be able to just slide it to land on top of the other. Okay, so that's why 3 is out. All right, just know like dilations as a concept. So dilations, the concept is like, let's say I have some triangle over here like this. If I dilate, let's say scale factor 2, what that does is like it doubles the distance from the center. So this is our center of dilation. It doubles the distance between the center and any point on our shape. So like this would go twice as far. This one here would go about here, twice as far. And then when I connect these points, you see how I get another triangle, and the triangle is facing the same direction as the original, and these two are similar triangles. Okay, so concepts really help. If you know the concepts, then it's like easier to get through these regions questions. Like you can get through the regions just by memorizing all the rules, but if you know why the rules work, you'll be in like amazing shape. Awesome. All right. Let's see. Question 9. Parallelogram. So draw. Yeah, with these questions, draw. Okay, you should absolutely draw pictures. All right, relevant to the test. Don't just draw like a giraffe or something. Okay, parallelogram A, B, C, D. Diagonals AC and BD intersect at point E. Cool, so I'm just drawing what they said. Which statement does not prove parallelogram ABCD is a rhombus? Okay, so if the goal is a rhombus, I probably should have read everything before I drew. Then I'm going to redraw this so everything is the same size, like all four sides are the same. Okay, so A, B, C, D, E. Okay, now we go through it. So AC is congruent to DB, does not work. I mean, we can even see here, like this one looks longer than this one. So that's not it. This proves a parallelogram is a rectangle. It does not prove a parallelogram is a rhombus. When you have congruent diagonals, that means you have a rectangle. AB is congruent to BC. This works. Consecutive sides of a parallelogram congruent upgrades your parallelogram to a rhombus. All right, AC. Oh, which one does not prove? Hello. All right, so that's why you go through all the answer choices, just in case you don't actually like read the question carefully the first time. You're like, wait a minute, these two things are true. We're looking for the one that does not. So the not answer. Yeah, the Regents is like kind of designed to be cruel. But look at that. Hey, that's like modeling actual thinking. So this would prove because consecutive sides of a parallelogram congruent gives you a rhombus. Perpendicular diagonals gives you a rhombus. And if the diagonal bisects the angle, that also gives you a rhombus. So which one does not prove would be, what's it called? Yeah, I'm sorry, this thing is like kind of taking over. It has a mind of its own. Would be 1, okay? That one would work if you're trying to prove a parallelogram is a rectangle. All right, so let me just draw this. Yeah, and you can even see just the way I drew it, like this diagonal is clearly longer than that one. All right, so that's why drawing is a very useful skill for the Regents. If you could draw stuff out, it just like brings the question to life. And I don't know why this thing is zooming on its own. Yeah, I mean, I upgraded my writing tablet, but it's like, I don't know. I have to like learn the ins and outs of it. It's like sort of like a little bit possessed and just like taking over. All right, let's try this again. Cool. All right. So in the diagram below, we have circle O, OB, OC are radii, and the chords AB, BC, and AC are drawn. Which statement must always be true? All right, the measure of angle BAC equals BOC. No, this is not true because this one here is inscribed. This is an inscribed angle, and this is a central angle. And what I could say is that the measure of angle BOC is like 1/2 of the measure of angle BOC is equal to the measure of angle BAC. Okay, the inscribed angle is half the central angle. The measure of angle BAC is half the, yeah, so like this would be 10, I can see right away is going to be choice 2. Okay, so this one is just the inscribed angles theorem. So like some rules, like you just got to know for the Regents. So just make sure you show up knowing that. So BAC and BOC are isosceles. That one, no, because A could be anywhere. A could be like over here. And then like see how the distance from A to C is not the same as the distance from A to B. All right, that's why this is not a must be always true. And the area of BAC, yeah, know what this as well. So this one is just the inscribed angles theorem. All right, cool. If they're shortening the reference sheet, then the test will be easier. Maybe. I hope they make it nicer, but we can't say for sure. Yeah, we're really at their mercy. We don't know necessarily what we're walking into tomorrow. But, I mean, look, for the most part, I think the Regents is going to be the same. Okay? All right. So a 20-foot support post leans against the wall. So draw something leaning against the wall. So right triangle question. Making a 70 degree angle with the ground. So this is 70 degrees. And the 20-foot post is going this way. To the nearest tenth of a foot, how far up the wall will the support post reach? So the wall is here, so how far up? We're looking for X. So this one, SOHCAHTOA. You need to know SOHCAHTOA. Okay? This is such an important thing to know in math because, like, you know, if you take physics, like, if you don't know how to do this, physics is a nightmare. Okay? So SOHCAHTOA, yeah. All right, so let's see. The angle is here. See how there's our angle is 70 degrees. This side is opposite. This is opposite of, but this is the $1 million phrase, opposite of the 70 degree angle. Okay, this side is next to, this is adjacent to the 70 degree angle. And the reason why I'm like writing all this extra stuff is because it matters like which angle you're talking about. Like if I solved and said, oh, this one's 20 degrees, then X would be adjacent to the 20 degree angle, but it's opposite of the 70 degree angle. Because the trig function, it depends on like which angle you're starting with. And then this, no matter which way we look at it, is the hypotenuse. This is opposite of the 90 degree angle. Okay, so here's the hypotenuse. So we're looking for the opposite, and we know the hypotenuse. So then O stands for opposite, H for hypotenuse, A for adjacent. So you're like opposite hypotenuse, and then sine should come to you. Okay, hopefully you see the sine. Okay, so sine of 70 degrees equals opposite over hypotenuse. So you set up the ratio. The opposite side is X over the hypotenuse is 20. And then call this sine of 70 degrees over 1, and you cross multiply. And you get X equals 20 times sine of 70 degrees. And then calculator. So you go to a calculator. Make sure you are in not radians. Mode, go to degrees. Okay, degree mode. You press 20, sine 70. 18.79. Okay, so we go 18.79, but we're rounding to the nearest tenth. So then we go here, 17, there's a 9, so we go to 18.8. It's kind of cruel that they make you do all this work, and they want to make sure you actually know how to round, because it's a Geometry Regents. They shouldn't worry about this. And all right, so depending on what grade you're going for, this is for the people who want like a 90 and up. The Regents, one thing that I think is very cruel is that the rounding is different for like every question. They're like, round to the nearest tenth, then round to the nearest whole number. Why don't you round to the nearest thousandth, and then the nearest hundredth, and then the nearest 10,000th? It's like, make up your mind. On AP exams, they're like, hey, how about every time we just round to 3 decimal places? And that's just the agreed upon thing. And there's no like, I gotcha questions like that. You know, there's traps and all that, but like some of the questions is just kind of like, gotcha. It was actually round to this. You're like, all right, -1. Like they could be kind of mean, but I mean, whatever. Okay, so that's the end of that. All right, this is a tough one. This one is like kind of tough because there's a lot of steps, but this is, you know, how to think your way through. So thinking is very valuable. All right, that's you happy because you're at a geometry live stream the night before your Regents doing more math. Okay, so a perpendicular bisector is, let me just draw something sort of random. So here's N and here's Y. A perpendicular bisector goes through, let me draw that again, goes through the middle and makes a 90-degree angle. So it goes through the middle and makes a 90-degree angle. So that's why we have to find the midpoint of NY. So we go -11 plus 5 over 2. See, this is like x1, y1, and this is x2, y2. So we add the x coordinates and divide by 2. Comma, we add the y values, 5 plus -7, and divide by 2. So the midpoint is at -6 over 2, comma, -2 over 2. So this tells us the midpoint is at -3, -1. Okay, so this is big because the formula that you need to write the equation of a line, there's 2 you could use. My students will like, I mean, not make fun of me, but it's kind of like having like old guy taste. you know, like everyone here is like basically Gen Z, but like when a millennial is like, hey, this is so cool, they're like, yeah, but like our stuff is better. This is the one most people like, y equals mx plus b. But this one, y minus y1 equals m times x minus x1, is a nice formula because there are questions like this one where they write all of the answers in point slope form. Okay, so here, now what I do is I basically ignore the labels I put on before. So I'm like, all right, get rid of these. Okay. Oh, I shouldn't have erased all of that stuff. That was like, all right. Oh yeah, because I'm just trying to erase the terms I don't need. All right, I guess that's good enough. All right, so the idea being that once I have this set up, so I'm here, and let me just fix this. Wait. All right, here we go. Is it back? Sorry, this pen is being stubborn. Oh, here we go. All right, now we're good. So once I have this, basically the midpoint, I'm going to treat as my x1, y1, because the line that we want, like this line is the perpendicular bisector. That's the one we want, and it has to pass through the midpoint. Okay, so it has to pass through that. So that's the point we're using to write our equation of a line. So we're going to have y minus negative 1. So y minus negative 1 becomes y plus 1 equals the mystery slope times x minus x1. X minus negative 3 becomes x plus 3. So you see how I have y plus 1 and then x plus 3? That eliminates these two choices here. So it's either 1 or 2. But now a little thought experiment. Do you see how ny was dropping? So I'm going to draw my good friend slope guy. When you have a positive slope, your line goes up. Wait, here we go. Positive slope, your line goes up. Negative slope, your line goes down. A vertical line, the slope is undefined. And for a horizontal line, you have a 0 slope. And it makes slope guy. If slope guy gives one of you a nightmare tonight, then slope guy did his job. No, that's just a little joke. No, slope guy is like really useful for like understanding slopes. So the point of this is like ny, see how the slope is negative since it's dropping? So the perpendicular line, the slope has to be positive, and out of the remaining answer choices, the one with the positive slope is choice 1. So that's how you could just kind of like thought experiment your way through. But if you want like the mathy way to do this, then what you do is you find the slope of ny. So you take the difference of the y values. So you're doing negative 7 minus 5. So you're doing like y2 minus y1 over x2 minus x1. And you divide by 5 minus negative 11. And now this becomes negative 12 over 16, which reduces, if you divide top and bottom by 4, to negative 3/4. But that's the regular slope of ny. The perpendicular slope, you got to find the opposite reciprocal. Okay, so we find the opposite reciprocal. So we change this to a plus, and then we flip this to 4/3. So that's where that 4/3 slope is coming from. Okay, so that would be like the last piece here. We would just plug in m is equal to, the perpendicular slope is equal to 4/3, and that's why we get choice 1. This would be parallel. Okay, parallel is when you have like the same slope. You have two parallel lines, the slope is the same because they have the same rate of change. They're going in the same direction. Cool. Question 12. That was a lot. All right, let's here we go. What's this one? Oh, this is probably like maybe like an altitude rule or something, or maybe something else. Yeah, this one's probably altitude rule. All right. So with the altitude rule and the leg rule, if you forget those, then you have to really be good at similar triangles. Like all those formulas could be proven, but you shouldn't forget leg rule. All right. Never skip leg day. Anyone lift weights here? Maybe, maybe not. Okay. Manifesting. Yeah, let's manifest those like hundreds. I hope everyone. Who started manifesting? Could someone let me know in the chat? Was it Israel Adesanya? Was it him? Did he? Because I'm old. You all got to teach me like where this stuff comes from. I think it might have been him, the UFC fighter. You started it, me. Okay, so thank you, Lefty, for making the nice phrase for us. Okay, so here we are. We are all passing. Don't say that, Mark. Okay. SU is equal to H. UT is equal to 12. RT, the whole thing, RT is equal to 42. And if I do 42 minus 12, that gives us 30. That's this piece. So RU is 30, UT is 12, and which value of H will make RST a right triangle with RST, that angle is the right angle. So this one, the altitude rule. I'll draw this off to the side. So when you have a right triangle like this, and let's say this is the hypotenuse. This is leg 1, part 1, part 2, and altitude. So these are like two rules that are like just about guaranteed to show up. But you could do part 1 over altitude equals altitude over part 2. All right, this is a good rule to know. All right, the reason this works, the concept is similar triangles. Okay, you have to be good at similar triangles for the regions. Okay, so just make sure you are good at those. So here, what we do is we just set up part 1 is 30 over the altitude H equals the altitude H over part 2 is 12. And then we cross multiply. H squared equals 30 times 12 is 360. And all the answers are in radical form. So we take the square root of both sides. And if you're like, oh no, I'm bad at radicals, like algebra 1 was miserable, then all right. Then you go like this. You go square root of 360. And you run through every answer choice. And by the time you get to choice 2 and you write in 6 square root of 10, so 6 square root of 10, you get the same thing. Okay, so if you can't algebra, I mean, like learn algebra, but you know, for the regions, then use the calculator. So at least you get it right. Okay, so this matches up with this. But let's say like, hey, I want to know how to do algebra. This is where like you got to know your times tables. So 36 times 10 is equal to 360. Okay, so this is a good rule from algebra 1. Radical AB equals this when, you know, A and B are greater than or equal to 0. You could break a radical by multiplication. Don't ever do this. Don't, because people make this algebra mistake all the time, and it breaks my heart. This is not math. Don't do that. That's bad. This is fine. This good. This is terrible. Okay, so 36 times 10. The reason I chose 36 is a perfect square. When you're simplifying radicals, you want perfect squares. So the square root of 36 is 6. The square root of 10 is just the square root of 10. And that's why you get choice 2. Okay. Why is rad 360 involved? Because to solve for h, we have to take the square root of both sides. With these altitude rule questions, if the altitude is the variable, you have to do square roots. Okay. So yeah. Oh no, I'm reading some of the chat stuff. Teacher told us his job ain't, you know, to teach you. Well, that sounds like a tough spot to be in, but, what's it called? Yeah, I'll do my best to teach you whatever I can from now till tomorrow. Didn't teach constructions. Yeah, constructions. I'm gonna have to open up Smart Notebook to do constructions, but I have a lot of videos on, and teachers said, whoa, everyone's just so honest about their teachers right now. Barely taught. Oh, so what do you all just watch movies all year? What's the? Oh wow. I hope my students aren't saying that I like to think I teach every day, but there are some circle stuff in here. Oh, the calculator thing again. Yeah. So I said do second x squared makes the square root 360, and then when I want to write 6 square root 10, I press 6 second x squared 10. Okay, you get the same thing. All right, this one is more perpendicular stuff. So we have a triangle. They gave us the vertices, like the actual coordinates. What is the slope of the altitude drawn from point A to BC? So the altitude is going to go like this. But the idea is it's perpendicular. So let's say I call this like, I don't know, point D over here. I would say AD is perpendicular to BC. So this means like the slope of AD is the opposite reciprocal of the slope of BC. Okay, and BC we can find the slope of because we have these points. The slope is y2 minus y1 over x2 minus x1. So now we just find the slope of BC, and this is the notation we could use. We use lowercase m, and we put BC as a subscript. It's a clean way to write it out. Okay, so this is like our x1, y1, and this is our x2, y2. So we go 3 minus 1 over 7 minus 2, which is 2 over 5. But this is the slope of BC. The slope of AD, or think of this as the altitude. The slope of the altitude is going to be the opposite reciprocal. So it's going to go from positive to negative, and it's going to flip to 5 over 2. So choice 4 would be it. Awesome. And my school have to pass geometry so you could graduate. Oh, I hope we all pass this. All right. Proofs are at the end, and it's a pretty nasty proof too. I'm like a little bit like, oof, we got to do this thing. But, oh, wow, 483 of you are here, 1650 total. This is so cool. Thank you all so much for being a part of it. I can't, say thank you enough. I mean, I teach like 100-something people a day, so the fact that there's like 483 of you here is like pretty wild. Thank you for being a part of this. All right, so all these classic questions here. All right. Let's see. So 15, trig, more trig, and similar triangles. All right, just know, similar triangles, trig and right triangles is like 37% of the regions. Okay, so just please be awesome at similar triangles. That means similar. Okay, be awesome at them. Which statement is always true? So with this one, what we need to know, for one, similar triangles have congruent corresponding angles. Okay, so that means here, and they put the letters in corresponding order, like E and J are the same. Okay, angle E is congruent to angle J. This angle here, angle JTM, is congruent to angle ERM. Okay, and then this right angle is congruent to this right angle. And I mean, it's a little sloppy that they said tangent of T, because technically I know T is this angle, but there's another angle happening over there. It's like, this is like, yeah, sloppy. So I'll write an angry email to New York State that technically you should only use one letter when it's like angle R, E, and J. T, like I know it's understood it's going to be the acute angle, but there's still this obtuse angle at T that kind of like throws the question off. Okay, so for this one, the idea is like I could say things like cosine of J is going to be equal to cosine of E, because J and E are equal angles. All right, so this one is like a lot going on. All right, this is trig ratios and similar triangles combined. So cosine of J is equal to, I go, remember SOHCAHTOA, cosine is adjacent over hypotenuse. So cosine J would be JM over JT. See, like JM is adjacent and JT is the hypotenuse of the small triangle, and this is the hypotenuse of the big triangle. Okay, but cosine of E is equal to, adjacent to E is ME. Oh, thank you at O Block. Thank you so much. I appreciate the tip. What's the altitude of the points DIH? Hang on, let me see. Is that the last question? DIH? Maybe I'm missing something. Wait, if you could be a little more specific at O Block, like what do you mean by the altitude of DIH? Just so I know what you're talking about. Because I don't know if that was in the last question. Or someone could, like, if someone else understands, like, what the question is, like, pass it along. That's, like, one of my rules for the class. Like, someone help me understand if I'm not understanding. So ME over RE. All right. Unless, oh, that's like a thing. Okay, that's like a phrase. Yeah, I'm showing my age here. Troll, got me. All right. Hey, good, comic relief. And wow, the camera's changing to make me look redder than I am, too. See, I gotta have like a Gen Z translator. Like, I know Cooked. I know, what's the other one? Riz and all that. Like, I've heard of. All right. Good. Hey, he tipped. He could troll. For $2, you could tip. All right. So, moving on. So, ME over RE. And now, all right. So, at Griffin Case, is this like a real thing? Or no, Centroid in center is a real thing. Okay. So, now everyone who tips, I'm going to be on the lookout for that stuff. But yeah, I could talk about those. Centroid in center and all that stuff. All right, let me look up. Was it something? Hang on, I gotta see. Oh, all right. I see. That was a bad word. Ooh. So he said a bad word. I just had to look it up on, which one was it? Know Your Meme, acronym finder. Oh, he said a bad word. All right. You get a pass, though, because he tipped. He paid $2 to say. Everyone gets one bad word, but not like too bad. Okay. That's my rule for the classroom, too. If you curse, you get like one free one for the year. So that was your free one. Okay. All right. Because it wasn't like hateful or nothing. Yeah, because the guidelines are like no hate speech or anything like that. But just saying, a bad word is like frowned upon, but whatever. Okay, back to the math. So here, like we go through this, you know the ratios. So this one is not it. Okay, one is not it. And we go through them one at a time here. And what's annoying is for this one, we got to go all the way down to choice 4 to show this is correct. So something like tan of E. Tan of E is opposite, which is RM, over adjacent is ME. Okay, so RM over ME. But like we said before, E and J are the same, so this is equal to tangent of J, but tangent of J is TM over MJ. Okay, so 4. All right. So moving on. On the set of axes below, rectangle ABCD can be proven congruent to rectangle KLMN using which information? All right, this one is very evil, okay? So we look at this one, and it's very tempting to just say rotate. But rotate is, I wish I had the bear ready. This is a bear trap. Because you're like, wait, why not? The letters have to land in corresponding order. So A has to land on K. And we need, if we change colors here, so yeah, we'll give this a second to actually load. I don't know why this is like, yeah. So B would map with L. Like this. And we also need, let's say, point C. Okay, actually, I'll do this one in red. Yeah, this one is like not changing colors like super fast, but doing my best here. Okay, C maps to M. So it's got to be reflect over the x-axis. Because yeah, they're like a mirror like distance away from the x-axis, these points that are color-coded. So the corresponding points, this is a big idea. And they're probably going to throw this in the new regions. Big idea is like corresponding points have to land on each other. Okay? So that's, that's the idea. All right, moving on. So this question, I feel like I've definitely done this question in class with my actual students from like school. We definitely went over one like this somewhat recently. So this one, 180 minus 115, will tell us this angle over here. Okay, because these make a straight line together. And that'll be 65. So now that we know this one's 65 degrees, we have vertical angles here. So these two triangles, the triangles are similar by angle. So AC is 6, DC is 4, FC is 15. Measure of angle D is 65. For this one, we're going to set up a proportion to solve for the length of CB. But the big idea is like we have to know which sides are. What if 100 on the G? Yeah, I mean, if you know all your stuff, old block, you'll get 100. So I hope so. But I don't. The secret to getting 100 is there's a lot of practice that has to go into it. So I mean, hey, if you're willing to put the time in, like, I have faith that people could learn 100% of the stuff on the Regents. Just depending on how much time you want to spend on this stuff. All right, so for this, we set up our proportions here. And what we do is, like, let's say I go x over 15. When I set this up, x over 15, you have to be able to think your way through these questions. See how, like, x over 15, I'm going from, like, the 65 degree angle to the vertical angle, like the vertical angle. And then I go to, like, the last angle. See, I'm going, like, 65 to the vertical to the last angle. And this one has, like, the vertical has, like, the single and the double. So you can even think, like, 65, and then it's, like, the single, and then, like, the double mark, like this. So when I go to set up my fraction or my ratio in the next triangle, I have to go that same exact path. I have to go 65 to vertical to double. So I'm going 65 to vertical gives me 4 over 6. And then just algebra, 6 times x equals 15 times 4 is 60. You divide by 6, and x is 10. Okay, so cool. All right, that's it. That's 17. Oh, I should be checking. Yeah, 17 is 1. All right. All right. This one was sort of like, I don't know, I feel like this one's like a little, like maybe a little outdated because it's like all algebra, the next question. So, but I mean, you have to know this algebra when you do volume questions and density. So seawater contains 1.2 ounces of salt per liter. So I just start writing this stuff down. 1.2, this is how you write ounces. You abbreviate it with like OZ. Ounces per liter. How many gallons of seawater to the nearest tenth of a gallon would contain 1 pound of salt? So if I go to the reference page, so on the reference page, we look and they tell us 1 gallon equals 3.785 liters. Okay, your reference page is going to be kind of weak. It's not going to have a lot. But because of that, they're going to give you this type of information. They're not going to make you memorize 1 gallon equals 3.785 liters. That's like kind of insane. Okay, so for this one, what we do is they're asking how many gallons to the nearest tenth of a gallon would contain 1 pound of salt. So another thing we need to know here is that 1 pound... So 1 pound equals 16 ounces, which is, once again, also on the reference page given to you. So when they say there's 1.2 ounces per liter, well, we could say, all right, well, then how about 16 ounces? That's going to be X liters. And then you cross multiply, and this is an invisible 1 in front. So we have 1.2 times X equals 16. And then from here, we divide both sides by 1.2. You type this in a calculator. 16 divided by 1.2 is not stressful to type in, so I'm just going to say 13 point repeating 3. So that's 13.3 liters. Okay, so we're going to have 13.3 liters. But now what they told you is that there's, if we look here, 1 gallon is equal to 3.785 liters. So then here, what I could do is I could say, all right, well, times 1 gallon over 3.785 liters. This is from Algebra 1. I don't know if you remember, conversion factors. Why would they change the reference? Well, they change the regions like every 10 years. What's it called? So, yeah, they change the regions every so often, and they do that, I don't know. Some might say the quest for more money. So, yeah. All right. So let's just see. So now we do times this. The liters cancel. And if you divide 13.3 by 785, this is going to work out to, 3.5 gallons. All right. I mean, that one I'll just show, like if I type in 13.3, that's 13.3 repeating. So it's like, 13.3 repeating divided by 3.785 gives you 3.5. All right. So it's just like algebra. They removed radians from the region, so that was nice of them. Oh, someone asked about the previous question. So with this one, if that didn't make sense, how I explained it, what you could do is draw the triangles so they face the same direction. Okay, so like if I draw the triangles, let's say like here like this is the 65, this is 6 and 4. And then I draw the other triangle, the bigger one, the same way. So the vertical angle is here and the 65 is here. Do you see how like between vertical and 65 is X? And then between this one and the, oh wait, I'm sorry, I should draw this way. Let me fix this up. Sorry, I was like, oh yeah, try this way. Yeah, this program is like a little annoying right now. It's like not as responsive. I think it's because, I mean, it's awesome that there's so many of you here, but this computer is like struggling to hang on. All right. All right, so 65. So I'm going to draw the 65 here and the vertical angle here. So if 65 were here and the vertical here, then this would be X. And then the other angle is like this one in this corner here. And from here to here would be the 15. So that's why like X over 15 equals 4 over 6. So draw the triangles so they face the same direction, and then the proportion step is easier. Okay, that's like a little trick you could use if like reading it all zigzagged is tough. All right, so back to 19. Line segment EA is the perpendicular bisector of ZT. So this is 90 degrees, and these are the same. And TE and ZE are drawn. Which conclusion cannot be proven? So, I mean, right away, like, see how they share this? So, like, triangle, and let me make this neater. Triangle ZAE is congruent to triangle TAE. Like this, and this is true by side angle side. So once I know these are the same, EA bisects ZET is going to be true because these angles I could prove are the same by CP, CTC. Okay, so that's going to be true. Which one cannot be proven? Triangle EZT is equilateral. I think that would be it. This one doesn't, because if this is a perpendicular bisector, and that's all we know, this could be like really tall, like this. And then you see how like this triangle is not equilateral. So like this is a perpendicular bisector, but this triangle is not equilateral. Even though they kind of drew it equilateral, which one cannot be proven? Like with proof, seeing is not believing. Okay, so like 2 is really looking like it. EA is the median is true because if this, the median is the line segment that, it's the line segment, it connects a vertex to the opposite midpoint. Okay. And then angle Z is congruent to, yeah, this is the isosceles triangle theorem. But once I know these two triangles are the same, then these angles are the same as well. So definitely 2. Can't be proven. All right. Hemispherical water tank. So half a sphere. So there's the water tank. And the diameter is 10. R is equal to 5. And water has a density of 62.4 pounds per cubic foot. Cubic feet is feet to the third. What is the weight of the water tank? What is the weight of the water in a full tank to the nearest pound? So the volume of a sphere, this is on the reference sheet, is this. But this is like a whole sphere. A hemisphere is half. So that would be the volume of a hemisphere. So I'll just say like HS is 4/3 pi r cubed, but like divided by 2. All right, so the volume of a hemisphere, in this case, is 4/3 pi. They tell us the diameter is 10. So the diameter is 10, tells us the radius is 5 feet. So I have like 5 feet to the third divided by 2. Just know on the Regents like don't write units, or like you don't need to write units. But just know next year or 2 years, physics, the units count. All right. I taught physics for 2 years. The physics Regents, like, whoa, like in the free response is so important. And all throughout the test, like unit analysis is big. That's why like I don't agree with the geometry Regents like not counting that, because like you kind of need it for your other math. Bring back the beard. Yeah, I shave. I don't know. But I appreciate the vote. Maybe someday I'll grow it back. It's just, I feel like it's just easier to go about your day not having one. After a certain point, it just gets annoying, and you're like, goodbye, beard. But some people just keep rolling with it, and I'm like, I respect their commitment. All right. So yeah, that's just side note. So now, all right, how to type this in so you don't make a typo. So you go to the calculator, and I like this one. Ready? Alpha, y equals, enter. Makes a blank fraction. You write 4/3. I like to write it in parentheses, although it doesn't matter if you don't write parentheses. Pi, and then 5 to the third power. Okay, divided by 2. So that's our volume. And then from here, what we do is we're going to multiply that by the density. Mass is equal to density times volume. So we go times 62.4. All right, let me see if this screen can handle it. Oh, it did. Cool. So I'm just going to borrow this. All right. Oh, no. Did I anger it? Okay. No, the program's okay. So the volume is equal to 261.799 cubic feet. But when we multiply 62.4 pounds per cubic foot, oh, yeah, pounds is lbs. That's pounds. The English language is cruel. All right, times 261.799 cubic feet. Cubic feet over cubic feet cancels. And it gives you 16,336 to the nearest pound, which is choice 1. All right. If you don't do the hemisphere, you do a full sphere, you're going to get like one of the wrong answers. So just be careful. All right. Moving on. Okay, 21. We've got AD is 24. DB is 12. DE is 4. What is the length of AC? All right, so I'm going to write this over here. Don't do this. This is a... Oh, what button did I press? All right, so trap. Do not do this. I see this all the time. People go, 4 over X equals 12 over 24. And then they're like, math, blah, blah, blah. X equals 8. And like, just no, okay? We can't do this here because this is not the side splitter theorem. This works if like this was 4 and this was X. Then yes. But the parallel line cutting through, we can't apply the side splitter to. All right? So this gets so many people. Every year I teach this, and I even warn them. I'm like, yo, like, don't do this. But like, if you're not paying attention, right, you miss this. So pay attention in class. Okay. So here, the way around it is you could draw the triangle separately. So I could draw, big triangle and then little triangle would look like this. Okay, so this is like DEB. And let me zoom out. I don't know why this, once again, this thing is like, okay, all right, that's better now. Yeah, I'm just making sure like we could actually see it too. Okay, so big triangle, little triangle. So this would be 4 and 12. And then in the big triangle here, this is ACB. So AC is X. And AB would be 12 plus 24, which would be 36. See, I have to add those two together. So I could say X over 36, left side over right side, equals 4 over 12. That works. Okay, you cross multiply, 12X equals 36 times 4 is 144. So that means that X has to be 12. All right, so just be careful here. Drawing the triangle separate is nice. All right, so moving on. How many square units are in the area of triangle? All right, this is a classic question. This shows up like almost every year. All right, if this is the year it doesn't show up, I'll feel bad. Okay, so let's see. So we got this. So what you do is you could draw a rectangle to inscribe the triangle. Okay, so that was not my best artwork, but this is a rectangle. And what you do is you find the dimensions here. So this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is going over 12, and it's going up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one is a 12 by 12. So what you do is you find the area of the rectangle, so 12 times 12, but then you subtract the area of these 3 right triangles. All right, this is probably the easiest way to do this. There's more than one way to do this, but this might be the easiest. So this right triangle here is 1, 2, 3, 4, 5, 6, and then 1, 2, 3. So this is a 6 by 3. This one, if this is 3 and this whole thing is 12, then that's 9 across. So this one over here, this right triangle, is a 9 by 12. And then this one, if this distance is 6, then this is 6. And then this is a 6 by 12 at the bottom. So we're doing area of a triangle is 1/2 base height. But remember, there has to be a 90-degree angle has to connect. The 90-degree angle has to, I'll say this. We need a 90-degree angle to connect the base and height. Okay, so the problem with this one is like, and maybe this is a right triangle here, maybe not, but like this method works no matter what kind of triangle you have. So I would learn this one. So now 1/2 base height, so I do 1/2, 6 times 12, plus I'm subtracting the small one here, the 6 times 3, and then plus 1/2, 9 times 12. Okay, so this is 144, minus half of 72 is 36, plus half of 18 is 9, plus half of 108 is 54, right? Yeah, 54. I mean, honestly, at this step, I would just use a calculator. Like, let's be real. You'll get these great machines to use for the test, so you might as well use it. So I go 12 times 12 minus parentheses. For 1/2, I just go 0.5 times 6 times 12, and then plus 0.5 times 6 times 3 plus 0.5 times 9 times 12. And we get 45. Okay, so it should simplify to 45, which is choice 3. But you know what, just to commit here, I'll just double check this way as well. 144. So this is 45 together. Plus 54 makes 99. Okay, and then if I got to do this math in my head, I just do 144 minus 100 plus 1. because minus 99 is like I could subtract 100, then add 1. So that's 44 plus 1, which is 45. Okay, so that works. All right. The 6-point question, it's a coin toss. It's either going to be a statement reason proof or a coordinate geometry proof. Those are usually the ones. All right. This question. All right, 23. Now we're 2 away from the free response, so that's nice. Okay. So for this one, let's just see here. We have a graph shows line segment AB, which is a chord of circle O. So a chord means like you have a circle. It connects 2 points on the circle. Doesn't have to pass through the center. Just connects any 2 points. The coordinates of the endpoints of A are here and here. All right, here we go. The distance from the midpoint of AB to the center of circle O is 2 units. All right. Well, if this is a chord and they're saying the center of the circle is 2 units away from the midpoint, for one, we should find the midpoint. You could just eyeball it like this and say like that's in the middle. Or the midpoint of AB, you could say is 3 plus 3 over 2. You just add the x coordinates and divide by 2, comma, and then you do 3 plus negative 7 over 2, which then tells you the midpoint of AB is going to be 6 over 2 is 3, comma, negative 4 over 2 is negative 2, which gives you, see, 3, negative 2. That's our midpoint. But they said the distance from the midpoint of AB, so that's here, to the center of the circle is 2 units. Well, that would mean the center has to either be 2 units this way or this way. Because it can't be 2 units this way, the center, because like A and B have to be on the circle. So that wouldn't work, because if the center was here, then the distance from the center to A would be less than the distance from the center to B. The center has to be the same distance from all the points. So that's why it has to be 2 units left or right. So this is the point, 1, negative 2. And this is the point 1, 2, 3, 4, 5, negative 2. So equation of a circle you should know for tomorrow is this. Equals r squared. So it's either going to be like x minus 1 squared plus, see, like x minus the x value is 1 plus y minus negative 2 becomes y plus 2 squared like this. So it's going to be something like this, or it's going to be something like x minus 5 squared plus y plus 2 squared. So it's going to be like one of those. So, one of the answer choice we could eliminate is this one, because it's all out of whack. But either way, like if this is the center, here like this, like let's say this is the center, then the radius is the distance from the center to A or B. And see how, like this one I can make into a right triangle and say, all right, I go over 2 and up 1, 2, 3, 4, 5. Okay, so if I make my right triangle on the side like this, where this is 2 and 5, then the radius squared would be equal to 2 squared plus 5 squared, which radius squared would be equal to 4 plus 25, which is 29. So the r squared would be 29. So these answer choices are out because r squared is 25. So it would have to be choice 1. Yeah, that's a tricky one. It's kind of like not nice. Are proofs congruence or similarity? Both. Yeah, they're both. I have, actually, this Regents has 2. What are some cheats on the calculator? So, look, that's a really good question. And I'm going to be sadly honest. It's really more useful, the calculator, for Algebra 1 and Algebra 2. Like Algebra 1, you could use the calculator to not necessarily pass the whole Regents, but it'll get you through a lot of questions without knowing algebra. So it's really useful. For geometry, geometry is more formulas and concepts. If you think of the math itself is not crazy difficult. If I look at some of the questions we've done, like this, cross multiply and divide. That algebra is not hard. What makes this question hard is you have to know what equation to set up. That's what makes geometry arguably the hardest of the math Regents. I even ask Algebra 2 teachers. I'm like, hey, do you think geometry is harder? And they're like, yeah, I think so. So I'm like, okay. All right. But, all right, moving on. What is the, whoops. Yeah, this thing, once again, is a little bit possessed. It's just it's hey, I'm going to zoom in times 12. like just out of nowhere. I'm like, okay, if you say so. All right, so here we are. So question 24. What is the area of the sector of a circle? So sector of a circle, we have a circle, and there's a central angle that's 60 degrees. So a 60-degree angle is like almost 90, but like a little less, like this. Okay, so this would be 60 degrees. So the area of the sector, the radius is 8. All right, so for one, you have to know the area of a circle is pi r squared. But this is like a kind of like a middle school, even elementary school concept. We're taking a fraction of this. Okay, so remember like elementary school, back when life was simple, or maybe not. So elementary school, we had like, oh, like this is 1/4. We're like, yay, math is easy. But like fast forward to geometry, and they'll do this. Or actually, I should say it like this. So they'll go, oh, wait, why is this? All right, it's not back. All right, you know what? Here, let me try again. So they'll go like this. Oh, now it's, all right, sorry. It's just like a delayed reaction. Here we go. They'll go like this in geometry. But then like the idea is like, hey, this is 90 degrees. So instead you're like, all right, 90 degrees over 360 degrees is equal to 1/4. So you see like it's still like the same kind of math, except now like they make it a riddle involving degrees. So pi times the radius squared, I'm doing pi 8 squared. This is like area of the whole circle. Okay, but we're taking a fraction of the area. We're taking 60 out of a full circle spins 360. So then this is 64 pi. 8 squared is 64 times pi times the zeros chopped. This reduces to 1/6. So now this is 64 pi over 6. And you're like, oh no, my answer's not there. So you just divide the top and bottom by 2. And this is 32 pi over 3. If you can't do that math in your head, like don't be sad. You could just do 64 over 6. Ready? And then you press math, enter, enter. And 32 over 3, and then just throw the pi on. Okay? So I could have even done that like at this step. Like say, all right, I'll leave the pi alone. I just do 8 squared times 60 over 360. And then math, enter, enter. And it simplifies it for us. Okay, so you don't have to do that math yourself. So there's some calculator magic for you. Oh, how do you know it's not S equals theta R? Good question. That would be if the central angle was given in radians. So apparently the buzz in the chat is like, no more radians. But like, all right, if radians still, then, and this is also arc length, which is a different notion. All right, so arc length, this would be the radius, and this is the central angle, but it's in radians. All right, then this formula works. But that concept still applies. So like arc length equals circumference instead though. Circumference is 2 pi r. So you ready? So it would be 2 pi r, but then I would multiply by the central angle. But in radians, I would be out of 360 degrees in radians equals 2 pi. Is 2 pi radians. So I wouldn't do theta over 360. I would do theta over 2 pi. You see how 2 pi over 2 pi cancels? It gives you r theta. So that's the proof of the formula. That's where it comes from. But it's the same like elementary school concept. That's the only reason why I'm able to remember all these formulas, is I know why they all work. All right. So 32 pi over 3, choice 3. That is it for the multiple choice. We are making progress. All right, we're an hour and 18 in. All right, and we're going to part 2. Describe a sequence of transformations that'll map this triangle onto triangle DEF. And we have to explain it. Okay, so this one, be careful. Take your time. Do not rush these questions. They are so easy to mess up. Okay, so this one, once again, I pay attention to the letters, A and D. So A has to go here. All right, the next one that has to map is B. Has to go, so point B has to go to point E. And then point C has to go to point F. All right. So now you think about this, like, how do I get there? Well, for one, like, could you kind of see, like, this has to flip over the x-axis. So flipping let's say I do the red one first. So I'll follow the red. So the red one, if we reflect over the x, see how it goes like 1, 2, 3, and then it goes 1, 2, 3 like this. So we go over the x, and then we go to the right, 1, 2, 3, 4, 5, 6. So that's my thought first, is like, all right, reflect over x, and then go to the right 6. But to be safe, we should absolutely check it for the others. Okay, so let's see. Reflecting b over the x goes 1, 2, 3, and then 1, 2, 3. And then to the right 6, 1, 2, 3, 4, 5, 6. All right, if I really want to be safe, I do that for point C. I'm going 1, 2, 3, 4, 5, 6 to the x, and then 1, 2, 3, 4, 5, 6. To the right 6, 1, 2, 3, 4, 5, 6. Definitely that. Okay, so now I just got to write it in words. And we're going, once again, from ABC onto DEF. So another thing to be careful of is whatever one you're like going from here like onto the other, like you start on this. Sometimes to be tricky, they'll make it confusing, like where do I start? But yeah, this is the idea. So I would say reflect. So reflect triangle ABC over the x-axis. Then translate 6 units right. All right, so that would get us full credit for question 26. Oh, this one's classic. All right, this is the classic, what's it called? Graph question. So this one, I'll show you formula and then like not formula. So here, let me see if I can take a screenshot of this stuff. If the computer can handle it. I think the computer's getting a little hot. Once again, I appreciate all of you for being here. 536 people, 3,252 total. This is, really, I thank you all for being a part of this. It's pretty cool knowing the review is reaching that many people. I started this channel out, a long time ago, and it's really cool to see that it made it this far, like this many people live, and then all the people like watching the videos too, like leading up to the test. And this is not where this is supposed to go. So let me. Yeah, all right. So concept plus formula. All right, this is being stubborn. All right, yeah, this is for some reason not. Oh, maybe I got to click here and paste it. Let me try that again. All right, still not wanting to go here. Maybe over here. All right, that will do. Yeah, probably off to the side is better. All right, so formula. So concept formula. Well, the formula x equals x1 plus p over p plus q times x2 minus x1. Where like p to q is your ratio. All right, so if you just want to have a formula to use, this is it. Make sure x1, y1 is the point to the left, and then x2, y2 is the point to the right. Okay, so yeah. So at Seabass, thank you for the tip. I did a question earlier. I want to say it was like question number. Oh, whoops! Don't destroy the microphone. Question 13. If you rewind back to 13, I did a question on that. Oh, Liam, thank you so much. I appreciate all these tips, everybody. This is like so nice of you. Thank you so much. Such a generous group. Drop $100. No, it's okay. That's quite all right. Just you all being here is more than enough, but I do appreciate. I'm gonna stream until I'm finished with this, and then I gotta go. Do some other stuff here. But yeah, I'm gonna go through this whole thing. I'm committed. So we got 4 over 4 plus 5 times x2 minus x1. So 22 minus 4. So this becomes 4 plus 4 ninths of 18. And then 18 divided by 9 is 2. So this becomes x equals 4 plus 8, which is 12. And then I do it for the y equals y1 plus p over p plus q. So now I'm going to have 2 plus 4 over 4 plus 5 is 4/9. And then I have 2 minus 2. Okay, like this. Which 2 minus 2 is 0. So this is just going to wipe out and equal 2. So point P is going to have an x coordinate of 12 and a y coordinate of 2. Now, what made this question actually kind of annoying is this is really far out. So using the graph is like not really going to be nice here. This formula, I don't know what it's called, to be honest. I'm sorry. The reason how I understand it, so concept is like pancakes. I'll say like ratio 2-to-1. So this is like flour, and let's say this is like milk or something. So I put these all in a bowl, and it's like, hey, that's 3 cups total. Because it's 2 cups of flour, 1 cup of milk, but it's like 2/3 flour, and then like 1/3 milk. You know, so like that's the, that's the idea, like kind of like why the formula is working here. So the way I think of it is like with this line segment here, is when we look at this line segment, we're going like a ratio of 4-to-5. That's like a really annoying one too. So let me think of it like this, like 1, 2, 3, 4, 5, 6, 7. Let me see. Is that 1, 2, 3, 4, 5, 6, 7, 8? One more. So a ratio of 4-to-5 would be if I looked at the point that was, let me see, 1, 2, 3, 4, like over here. So like this is the idea, like 4 equal pieces left, 5 equal pieces right. So this point, like P is 4/9 of the way from A to B. Okay, so like that's the kind of like the pancake concept. Like I'm baking pancakes, 3 cups of ingredients, ratio 2 cups flour to 1 cup milk. So like 2/3 is flour, 1/3 is milk. Like that's how I understand like why it's like P over P plus Q. All right, like you see how it's like 2 over 2 plus 1 would be like 2/3 flour. So like that's the idea. But like we're starting at x equals 4. So we're starting at 4 and then we're going 4/9 of the way from 4 to 22. But from 4 to 22 is a jump of 18. So we're going like 4/9 of that, starting at 4 though. It's like, so that's how I'm able to remember this formula. It's like I just understand why it works. All right. So that stuff, centroids, orthocenters, and all that. Yeah. Someone asked about that before too. So, so in center is, all right. So an in center is like the 3 angle bisectors. So like you have a triangle, and like, so angle bisector 1, angle bisector 2, and then let's say like angle bisector 3. Like that would be the in center. The other kind is the circumcenter. And that's like the 3 perpendicular bisectors. Okay, so if I do a different color here. So that's like, you know, perpendicular bisector 1, 2, and then like, whoops, bad artwork. And then like third one, let's say here like this. And this would tell you like the center of the circle that hits like all 3 points of your triangle. So if like I drew a circle like this, like that's the circumcenter, is the 3 perpendicular bisectors of the sides. All right. And then the last one, the orthocenter. So if they're throwing this back on the Regents, that's like, yeah, I mean, I saw in the samples that they mentioned the circumcenter, but I didn't hear them say the others, but I know on like we use Delta Math for homework in my school that they might have casually dropped those in. All right, so let's see. So the orthocenter is like the 3 altitudes. All right, so if I have a triangle yet again, like this, like so there's like altitude 1. And then like this altitude here would be 90 degrees to the base. So it's like going, you know, this way. And then for the, see, like this is like the side opposite. And then this one would go, I kind of made this one into a right triangle. So let me make it like a more interesting triangle. So something like this. So the altitude to this side would go here like this. All right, to the 90 degrees to the side opposite. So if I have this vertex and I'm 90 degrees to the side opposite, I would go, you know, here like this. So this one's going to go like down more. Yeah, this is like a better example over here. So this one, this one, this one, and then like this one, 90 degrees to the other side would go here like this. So see how like these are the 3 altitudes out here like this. So the altitudes, let me just make them a different color so they pop. So here's like altitude 1 extended. This is altitude 2. And then like you have to extend the side here like this. All right. What throws people off is when you're making the altitude for, let's say you have like something obtuse and I want the altitude here. I don't draw it into the triangle. I have to extend the bottom so that the altitude could go like 90 degrees. It's kind of like if this were like imagine this were a giraffe and you have to like measure his height. Like, so like there's the giraffe, like, you know, sorry, not my best artwork. All right. So there's the giraffe, like you're measuring his height. You're not going to measure like diagonally into him. You're going to measure like from his head straight to the ground. Okay. So giraffes help. But yeah, someone asked, so I had to say it. All right. So that's that. All right, explain why. So there's an easy way to do this and a nightmare way to do this. So why is AB parallel to CD? All right, the easiest way to do this, I think, is this is called the converse of the side splitter theorem. Okay, so here, the math you got to show is that the sides are being split proportionally. So when AB cuts through, we could say here 3.75 over 5 is equal to 4.5 over 6. If I had to show that work, like this is true because if I have to use a calculator, 3.75 over 5 is equal to this, and so is 4.5 over 6. Okay, they're both equal to 0.75. So I mentioned that in my explanation. I say, okay, yeah, 0.75. So we'll just get this set up here. Equals 0.75. So this means that, now I'll just write this extra step. So this means that EA, see EA is the 3.75 over AC equals EB over, what this tells us from here, we could say, like this means AB is parallel to CD because side AB cuts, let me just, yeah, sorry, this zooming thing is annoying. Kind of broke my flow. All right, and then zoom left. Yeah, I got to learn, there's like a probably something I'm pressing on the pen that's like making it zoom, but whatever, one of these days I'll master it. All right, so AB is parallel to CD because AB cuts sides EC and ED proportionally. Therefore, AB, this means therefore, 3 dots, is parallel to the third side. Okay, so the side splitter theorem, like regular side splitter, says that like if you have like two, like you have a triangle like this, and then like let's say DE, and then like DE parallel to BC, means that the ratio AD over DB equals AE over EC. However, the converse we say is true, the flip. If the two sides are being cut proportionally by some line going through the triangle, then the line going through the triangle is parallel to the third side. Okay, so this is like probably the cleanest way to explain it. You just show that the sides are being cut proportionally. So you can say, hey, EA over AC equals this. So then the lines are parallel because AB cuts sides EC and ED proportionally. Therefore, it's parallel to the third side. All right. So a little bit like sort of like a proof style question. All right. Why did this not? Oh, wait a minute. Why is that not pushing the other one down? Wait, let me see. Maybe if I drag this here and I scroll. All right, you know what? Yeah, that's what's nice about Microsoft OneNote is it has like this like infinite canvas. So I could just do stuff like this. All right. So this will have to do. Sorry, it's a little sloppy, but it's like the best I could do right now. The program is like, I think, freaking out because I did so many questions. All right, so here, big idea. Sine A equals cosine B when A plus B equals 90 and A and B are positive acute angles. Okay, so this is honestly like going to be my explanation because explain your answer. So this one, I could say R plus 73 equals 90. So if we subtract 73 on both sides, this tells us R equals 17. Okay, so here, once again, I could say R is equal to 17. They should have put R degrees, but whatever. R is 7, like the angle is 17 degrees. The fancy vocab for this is these are called cofunctions. But if you can't remember the word cofunctions, then you could just say, sine and cosine. This is their birth certificate names. Sine and cosine are equal when, or I could say equal when we plug in complementary angles, positive. How about this? How about sine and cosine are equal when we plug in positive acute angles that are complementary. Okay? That's like what this theorem is basically saying. Or you could say sine and cosine are cofunctions, so they're equal when we plug in complementary angles. So there's that. All right, this one. Sorry if it's like a, you know what, I'm just going to cut this. And because we already did that, so now I could just magnify this one. Yeah, if you got to like rewind or something, just rewind. Okay, so here, so let's see. All right, in the diagram below, we have circle 1. Sorry, it's doing that annoying zoom thing again. Okay. All right, so you got circle 1 and circle 2. Dominic thinks angles A and B have the same radian measure. State whether Dominic is correct or not. Explain why. All right, in circle 1, we have a radius of 4, arc length pi. All right, that's the formula someone was commenting before. So S equals R theta. So this is arc length, radius, but this has to be the central angle. It has to be in radians. All right, don't use this formula if degrees. Okay, so here, I would say like, all right, I'm using S equals R theta. So in circle 1, so S equals R theta, we would have the arc length is pi. So we have pi equals radius 4 times theta. So divide by 4, theta equals pi over 4. in circle 2, so circle 1, circle 2, the arc length is 13 pi over 8 equals r is 6.5 times theta is the mystery. You divide both sides by 6.5. That's the same thing as multiplying by 1 over 6.5. But if I do 13 divided by 6.5, that's 2. So this tells us that theta equals 2 pi over 8. And 2 pi over 8 simplifies to pi over 4. So is Dominic correct? Yes. Explain why. This is kind of like an annoying explain why, because I'm just like, I use the formula. So Dominic is correct. I'll just say that. Using S equals R theta, we can show that, you know, oh, how about this? I'll say like, so we'll say angle A and angle B are the same. You know, let's see, show that, I'll just cross this out, that angles A and B both equal pi over 4. All right, this is like a 2-point question, so it shouldn't be like too crazy to write out. All right, moving on. No, arc length formula you might have learned with like degree measure, but it's still good to see. It's still geometry. All right, a ladder is leaning against the building, and the top of the ladder touches the building 10 feet above the ground, and the foot of the ladder is 4 feet from the building. Find to the nearest degree the angle the ladder makes with the level ground. So that's this. So see how this is opposite and this is adjacent. So SOHCAHTOA, we use tangent. So I could say tangent of theta is equal to opposite over adjacent. But to solve for theta, the opposite of tangent is tangent inverse of the ratio. So theta equals, we go to the calculator, second tangent, 10 over 4. Once again, if you could do this, physics will be easy next year. Easier, not necessarily easy. All right, if you can't do trig, physics is a nightmare. So be good at trig. Okay, so this equals, to the nearest degree, 68 degrees. All right, so let's see. Yep, 68. Cool. All right, so that's 30. 31. Love 31. All right, compass. You know what? Just for all of you. Let me see. So smart. I hope this doesn't crash it. Please don't crash on me. Proofs are at the end. We will do proofs. All right. And thank you for the tips, everybody. Yeah, once again. There's like probably more people out there. But thanks for the support. Yeah, I appreciate like how many of you have come on. And if you haven't done so yet, please, you know, consider subscribing. Support the channel. It really does help, you know, every subscriber I get. So yeah, I'm trying to get to, I mean, no particular rush, but I'm at like 42,000-ish subscribers. So, I mean, the higher we could go, the better. Just want to be able to help more people. That's the goal. All right, so this one, they want us to construct, so using a compass and straight edge. Yeah, I had this saved on my other computer, and then like my whole computer just like gave up on me today. So I had to set my laptop up. That's why I feel like I'm just not like, you know, as smooth here. All right, so let's see. We got this. So yeah, I'm doing this just so I could use the compass tool and you could actually see it. And then I'm going to close this program out, the Smart Notebook, so that, because I feel like I'm like really risking things here, that things won't crash. So please don't crash. Okay. All right, so there's the circle, and we have to use a compass and straight edge to construct a line tangent to circle O at point A. So this one, what you do is you extend it. you go like this. Same direction. Let me line that up. So like that. You go through A. And then you get a compass. And you open it up. You go to the point of tangency. And you go 1, 2. You don't change the length for these two. Then you move it to the points. Then you open it so that it goes past A. Because if I don't change it, it's just going to meet right back at A, and it's not going to tell us anything exciting. So I open it, and I go 1. I go to the other point of intersection, not the center, and I go 2. And you know you did this right if when you connect this point to A, it makes a 90-degree angle, which it does. Okay, so this is our line tangent to circle O at point A. All right? Cool. So that is, I think this might have been like one of the more recent regions. They reused this one. So, yeah. All right. So let's see. Moving on to... All right, I'm going to get rid of this now. Say goodbye to the compass. All right. So now back to this. In part 3, 4 points each. A large barrel of fuel is a right circular cylinder. So here's the cylinder. All right, something like this. Diameter is 22.5. So the radius I could just divide by 2. It's like almost always what you have to do. So it's 11.25. The height is 33.5. And this is inches. So inches, inches. And they tell us, let's see, 231. Oh, at AKYA. Thank you so much. I have, so the January 25 Geometry Regents, I have a whole video where I did the entire walkthrough on that Regents. So that one, yeah, if people want like a good resource to use, I'll give you my, I have a playlist on, what's up? Oh, what's up, Kelvin? So yeah, also hello to my people in person, like the ones who are in my class. Hello to you all. Shout out to, periods 5, 6, and 7. Hope you're all doing well and ready for this test. All right. Oh, Brax, hello. Yeah. Oh, but say nice things. That's like kind of hate speech. I don't like that. All right. Yeah, remember, people, the guidelines are there and they're important. So please don't say anything not nice. All right, keep it real while we're here. All right. So let's see. Playlist. Yeah, I would rather people say nice things. Like, I do appreciate like people, when they tip, but like if I had to choose like tip with saying something hateful versus no money but being kind, I would choose no money, be kind. All right, so, yeah. All right, let's see. So someone asked about like a certain Regents. So let me just share the actual playlist. Hopefully this works. All right. Okay. So that'd be it. All right. So coming back to going over the questions. Okay, so this, we have 231 cubic inches of, make that a little neater. So 231 cubic inches in a gallon. So this is going to matter like a little bit later. Okay, so determine and state to the nearest tenth the gallons of fuel that are in a barrel of fuel oil. So here, the volume of a cylinder is pi r squared h. So we do the volume equals pi times, and then we have, let's see, r squared. And then the height is 33.5. So we do this, and this is going to be in cubic inches. So is everyone okay? I mean, I guess I could show just typing this in the calculator. So pi times 11.25 squared times 33.5. Okay. We get 13,000. I'm just drag this over here so we have it for later. But then we're going to have to divide by 231. All right, so I'm going to borrow that too. All right, and I'll explain why. Like, I have a students that'll like always mess. Like, this is like a tough one that they mess up. Like the non-geometry part could be tricky. All right. So let's see. Volume equals, and we get, let's see, 13,319.86198 cubic inches. But now some students are going to mess up and multiply by 231. The reason why you don't multiply is the units. That's why, like, the units are not part of the grade, but I think it's important to know them. So, like, the number of gallons of fuel, I would take the volume. So I take this number, and it's cubic inches, but I'm not going to multiply by this because that would be inches to the third times inches to the third, which would be inches to the sixth. I'm going to say, like, this is 1 gallon. I could multiply by, for every 1 gallon, there's 231 cubic inches. And now the units cancel, but we do this number divided by this number. Oh, thank you for the tips. I do appreciate this, by the way. This is like maybe like probably the most tip heavy group I've gotten. So thank you all. I appreciate you all being kind. So here to the nearest tenth, we have the 0.1, and we're gonna round using that 9 to bump this up to. Oh wait, I made a. I'm sorry. This is from tangent inverse. Forget I said that. So, yeah, this is out. So we had, this was 13,319.8618. We divide by 231, and we look, in the 10th place is a 6. To the right is a 6, so we're rounding up to 57.7. Okay, gallons. So there's our answer. So I got 3 monitors. I have OBS, I got the chat, and the YouTube, and I have the middle. All right, so moving on. Okay. All right, let's see. So next, a proof. Here we go. So parallelogram ABCD and diagonal. So, all right, all proofs, you have to write out the all right, hang on a sec. Yeah. Let's see. Hang on one second. I'm just like. I just, taking two. Yeah. All right. Let's. Okay. So, yeah, just muting, because I said, anything like hate speech, foul language, whatever. So, just had to mute. So, yeah, please keep it real in the chat, or you will be muted, and no one will be able to see what you say unless you make like 10 accounts and you keep coming in, like I've had people do in the past. Alrighty. So, moving on. Now we've got statements and reasons. So, statements and reasons. So, statement 1, parallelogram ABCD. You are allowed to abbreviate parallelogram like this if you don't feel like rewriting it over and over and over. We have line segment EFG and, whoops, diagonal DFB. Okay, given. All right, cool. Number 2, we have, now from here we go. So when they tell us this is a parallelogram, our goal is to prove that we have 2 similar triangles. All right, and this is a 4-point proof, which means it's not going to be like as devastating as the last one. So we're proving these triangles are similar. So the theme here, the strategy that comes into mind for me is angle, angle. Now I'm like, all right, these are going to be the same because alternate interior angles. So those are going to be the same. And then I could say like these angles are going to be the same because vertical angles. Now what I like to do is I like to put numbers. So I would say like angle 1 and angle 2, and then like angle 3 and angle 4. You are allowed to number your diagram. And then from there, you number the diagram and you could use that in your actual proof. So I could say like statement 2, I could say, well, this is the catch. This is a common mistake. If I just say angle 1 is congruent to angle 2, I'm going to lose points. First, I have to say that segment DA is parallel to segment CB. And then the reason, opposite sides of a parallelogram are parallel. Then I could say alternate interior angles. So when parallel lines are cut by a transversal, the alternate interior angles formed are congruent. Can I have your autograph? Here. There's the autograph. All right. Thank you for the tip, Ren. Thank you so much. All right, let's see. So this now establishes angle 1 and angle 2 are the same. I could also say this one and this one are the same. That probably would have been a little faster. But I will target 3 and 4 instead. That way we get more practice with vocab. So I could say, angle 3 is congruent to angle 4. And for this one, I could just say vertical angles are congruent. But if you want to be really fancy, intersecting lines form congruent vertical angles. Okay, so that's the idea. And then 5, finally, I established my 2 pairs of angles were the same. So now I can say triangle DEF is similar to triangle BGF by angle, angle. All right, that's it. Yeah, manifest those 80s, manifest those 100s, all that stuff. Manifest everybody passing. The test will be curved. So, yeah, it will be curved. Oh, thank you for the change in curriculum. Let's see. Change in geometry curriculum is because they didn't give us like as much guidance as they should have. Yeah, so let me. Oh, Geometry, State Education Department. Next Gen Standards. So, I mean, these, here they are. All right. That's the government site. So, that's, let me just see real fast. I'll be done in a few. Let me go to that site. Transformations in the plane. I mean, yeah, I mean, so this one, if like you just read through like those, like the things that I linked is, yeah, I mean, I could just pull this up on this page here. Like this is what we're all like potentially going to be, yeah, just looking at here. You know, like I could like read this stuff. Oh, Jonas, thank you so much. Thank you. So, yeah, I mean, like this site, it's just like kind of like this dry PDF, but they're like next gen learning standards. And like they'll say like these are the things that are, you know, changing. And it's like experiment with transformations in the plane and like no precise definitions of angle, circle, perpendicular lines, and so on. Given a regular or irregular polygon, describe the rotations and reflections that carry the thing onto itself. So there's a lot of, you know, overlap here. This one, though, the inclusive definition of trapezoid will be utilized. Quadrilateral with at least one pair of parallel sides. So like stuff like that, if you read through the right side here, this will kind of put those things. A translation displaces every point in the plane by the same distance and can be described using a vector. All right, so yeah, this stuff here, when they released it, it's oh yeah, so the postulates for proving congruence is still there. So they got all the stuff. Multi-step proofs, algebraic problems. The sum of the interior angles is 180. Exterior angles is equal to the sum of two non-adjacent. So that's the exterior angles theorem. So there's a lot of overlapping stuff. Yeah, once again, inclusive definition of the trapezoid. So this is the stuff. All right, the constructions. Copy line segments. Bisect. Construct perpendicular lines. Construction of transformations. Construct the inscribed circle of a triangle. So the inscribed circle of a triangle, yeah, like these are all fair game now. Centroid, circumcenter, incenter. Yeah, so it's good that people asked about that stuff earlier in the stream. Perpendicular bisectors. Yeah, it's got some good stuff. Special right triangles. Yeah. All right. This is good to, you know, definitely good to know here. And let's see. I'm trying to think if there's anything like brand new, like that's really jumping out. Because I'm just like kind of skimming here. Midpoint formula. Yeah. I mean, that area of a triangle formula with trig is a good one that I have on that other video. But yeah, I'm glad you brought that up though. Like those are definitely like good things to consider. So that link that I posted in the chat, I would definitely like read through if there's like any last minute topics you're like, ooh, maybe. But it's kind of annoying when they make a new Regents. They're like kind of like cryptic. It's just like, oh, here's 8 questions for you to read about. So yeah. Nabil, thank you for the vote. But top 3, yeah, that's yeah. I appreciate you saying something nice, but I'm just happy to help you all. We'll just leave it at that. All right. So triangle ABC is going to map to A prime, B prime, C prime. Describe the transformation that was performed. So this one, it's definitely a dilation. But if I look at like point B prime and I like follow like this, brings me here, A prime back to A, brings me here, and then C prime to C. Whoops. Make that a little neater. Brings me here. So it looks like the dilation is centered at 0, 0. But now for the scale factor. Well, for one, BC is equal to 1, 2, 3, 4, 5, 6. And then B prime, C prime is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So to find the scale factor, I would say 6 times K equals 15. And then just divide both sides by 6. So K is equal to, if you divide top and bottom by 3, is equal to 5 halves. So the transformation, we would say dilate. Well, let's think about what the question is asking. There was a transformation describe the translation. So I'll say a dilation. I'll just say it like this. A dilation with a scale factor of 5/2 centered at 0, 0. Okay, maps ABC onto A prime, B prime, C prime. Explain why they're similar. Well, dilations preserve angle measure. So angle A is congruent to angle A prime, and angle B is congruent to angle B prime. Therefore, triangle A prime, B prime, C prime is similar to triangle ABC by angle, angle. Okay, so that'll be it. So the angles are going to stay the same. All right, part 4, the final bosses here. All right, I do have to like move through these like, you know, a little bit quicker here because I do gotta run in a little bit. So I'm just gonna kind of just go through these, and I'll just say like, you know, a final farewell at the end, wishing everybody luck. So statements, reasons. This one was like a weird proof. It was like prove 2 things at once. So prove ACD is isosceles and that AEB is a right triangle. So 1, we have quadrilateral ABCD with diagonals AC and BD that bisect each other. And we have angle 1 is congruent to angle 2. True because given. All right, so we need a strategy here to get through this. So we have a quadrilateral. We're told that this is angle 1 is congruent to angle 2. So we have an angle bisector here, but we're also told that AC and BD bisect each other. So right away, like what's jumping out at me is like, all right, these line segments are the same and these are the same. But our goal is to prove ACD is an isosceles triangle. So the way we could do this, there's a few different ways we could go forward with this. But one way here would be to prove, and let me just make sure moving on here to, you know, the next set. It's a sneaky rule, but we can say ABCD is a parallelogram. All right, ABCD is a parallelogram. And the reason is if the diagonals of a quadrilateral bisect each other, the quadrilateral is a parallelogram. Okay, so if the diagonals of a quadrilateral bisect each other, the quadrilateral is a parallelogram. And now that we know this is a parallelogram, what we could do is we could now start targeting the angles involved. Okay, so now what I'm going to do is I'm going to call this angle 3 and angle 4. Because once this is a parallelogram, like we know these are the same, I could say that angle 3 is congruent to angle 2. And I could say angle 1 is congruent to angle 4. All right, but in order for me to start using the alternate interior stuff, I have to mention first that BC is parallel to AD. And I have to mention that AB is parallel to DC. All right, opposite sides. Of a parallelogram are parallel. All right, and then once we have this, once again, I could say angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. All right, so 1 and 4 are congruent because they're alternate interior, and then 2 and 3. If I don't mention the parallel lines, then I lose points. All right, I lose 1. All right, and this is when parallel lines are cut by a transversal, the alternate interior angles formed are congruent. All right. So, yep. So that's establishing this. But now, like, let's think. So what we said, let me just move this over. Like this is like, sometimes you got to stop in proofs and think. We have angle 1 is congruent to angle 2. Like, you know, and my goal here is to prove that this triangle is isosceles. All right, I want to prove ACD is isosceles. So far, like we have angle 1 is congruent to angle 2 from the givens. Okay, so we have that. And let me use the mouse because this is like just not responding. So angle 1 is congruent to angle 2. But we also said that angle 1 is congruent to angle 4. So if angle 1 is congruent to angle 2 and angle 1 is congruent to angle 4, this means that angle 2 has to be congruent to angle 4. This is the transitive property. All right. So honestly, I didn't even need to say this part. The angle 2 congruent to angle 3 is like, this one is like extra. Don't actually write extra at the Regents, but this one is extra. All right, because then now I could say the one I need is 2 and 4 are the same. Angle 2 is congruent to angle 4. And this is true by the, you know, transitive property. All right, transitive property for equality. Remember, it was like if A equals B and B equals C, then A and C are equal, like this. So like, yeah, like if angle 2 equals angle 1 and angle 1 equals angle 4, then like 2 and 4 are the same. It's like basically transitive property, we could say here. And then once we have that, now I could say, you know, triangle ACD. So triangle ACD is isosceles. And the reason, if a triangle has two, you know, congruent angles, the triangle is isosceles. Okay, because two angles are the same. But now this, I could say, now that I know this triangle is isosceles, I could say that this side, AD, is congruent to AD and DC are the same. Because if the base angles are the same, the sides opposite have to be the same. So now I could say AD. So AD is congruent to DC. And then reason in a triangle, the sides opposite. Well, Will, thank you so much. Do you think I'm going to pass the Regents tomorrow? I hope you do, Will. I believe in you. All right. Study up. In triangle, the sides opposite of the congruent angles. So in a triangle, the sides opposite of the congruent angles are congruent. All right, but now think about this. If you have a parallelogram, so we have ABCD as a parallelogram, and the consecutive sides, a pair of consecutive sides are congruent. That upgrades this to a rhombus. And then once we say like, hey, I have a rhombus, that means that the, you know, diagonals are perpendicular, which would make AEB a right triangle. So that's going to be like the close here. It's going to be a lot to write, but let's go ahead and write it. So now I'm going to say here, ABCD is a rhombus. Reason, a parallelogram with a pair of congruent consecutive sides is a rhombus. Oh, whoops, I ran out of space. Hang on. Is a rhombus. Okay. And then once I know this is a rhombus, the diagonals I could say are perpendicular. So AC is perpendicular to BD. So AC is perpendicular to BD, and we could say the diagonals of a rhombus are perpendicular. And once I know my diagonals are perpendicular, the goal is to prove AEB is a right angle. I could say I could say angle AEB is 90 degrees because perpendicular lines form right angles. Okay, so angle AEB is a right angle because perpendicular lines. This one's pretty nasty. Form right angles. And then finally, triangle AEB is a right triangle because a triangle with a right angle is a right triangle. Okay. Sorry, that one's a little fast at the end, but that's, yeah, just like summarizing here. It's a right triangle because it has a right angle. Cool, cool. All right. So that's that. And now let's see next. No, this proof was bad. That's why I chose this Regents. I chose this Regents for two reasons. Because it was like really long ago, so your teachers might not have done it. And like the proofs were kind of hard. So if the proof is easy, then like, yay. But you got to, if you want to go for a high grade, you got to be able to do the worst. All right, so now last question. Another 6-pointer. This is when they used to have 2 6-pointers. So a water glass can be modeled by a truncated cone. That's a cone that's been chopped. And the cone which is cut parallel to its base. The diameter of the top of the glass is 3. So this space going across is 3 inches. Across the bottom is 2 inches diameter. So that's the first radius is 1.5 inches. And then the second radius at the bottom is 1 inch. And then what they have here, the height of the glass is 5. So this height over here is 5 inches. So in this one, it's like 5 inches. And then this is, 1.5. And then this one is 1 inch this way. But they say the base with the diameter 2 inches must be parallel to the base with the diameter of 3 inches in order to find the height of the cone. Because the height of the cone is like the entire distance here. Like what is like the distance like going this way. And the reason for that is we need similar triangles to find the full height. Because this is like kind of what's happening here. We have like these 2 right triangles here. And they're similar because they share the angle at the bottom. But this only works if these are parallel. Okay, so first part is like, why do they need to be parallel? Whoops, let me just zoom out a bit. And we'll just, write that one out and say they need to be parallel. The bases must be parallel or have to be parallel. Whoa, thank you again. This is like very generous of you, but yeah, I appreciate it. Thank you so much. Low key pray. Yeah, I hope you pass. I really do. I hope you all pass. I'm rooting for everybody. Okay, so the bases have to be parallel. So we have. The bases must be parallel to make the right triangles similar. This allows us to set up a proportion to solve for the height. Okay, so that's like why we need them to be parallel. So we could do this to solve for the height. And now they tell us to determine the height of the larger cone. So you see how here, like if this is 1.5 the radius, and this distance is 5, and then this one is 1, and this is, let's say, x. Now what I could do is I could say, and I'll draw this over here, like the big triangle and little triangle. So the big triangle is 5 plus x and 1.5. And the little triangle is x and 1. So then if I drag these two down here, so let me write it over. Whoa, this is really, hang on, zoom out. Yeah, that went like times 200. Okay, let's go back to times 90. So I'm going to borrow these two here. So let me hope I could just like take a screenshot of this and then drag it down. All right. Just so we don't forget the math we just did. Yay, it stayed. Okay, so now back to drawing. And this allows us to set up, I could say x over 1. So I'm going to go left side to the horizontal side equals 5 plus x over 1.5. So we cross multiply 1.5x equals 5 plus x. And now minus x on both sides. And we get 0.5x equals 5. And then just divide both sides by 0.5. So x is equal to 10. All right, once we get to x equals 10, this is the height. Well, no, this is not the height. The height is 5 plus x. So the height, see how it was 5 plus x is 5 plus 10, which equals 15. Okay, so you see, yeah, the height, like this piece was, the full height is h, but if I call that piece x, then 5 plus x was the full height. So the full height is equal to 15. Okay, and now that we have this, determine and state to the nearest tenth of a cubic inch the volume of the water glass. Well, if we look at this thing again, see the big cone is radius 1.5 and the height is 15. So we're going to do the big cone minus the little cone at the bottom. Okay, so for this one, so let's see. Yo, all right, Will, thank you. This is, yeah, very generous of you. Thank you so much. But yeah, what's it called? Yeah, Mr. Beast in disguise, right? Yeah, if Mr. Beast was at this live stream, imagine, that'd be something. But yeah, thank you. No. Will, that's plenty. I do appreciate, the recognition here, but yeah, you all just being here is more than enough. So thank you. I'd rather you just like from here on just worry about the math and stuff, but I appreciate the the vote of confidence here. So volume of a cone is 1/3 pi r squared h. So the big cone has a height of 15 and the radius was 1.5. So I'll just say, let me say it like this: the volume of the water glass. All right, and rule of the region, stay inside the lines, but just for the sake of like not writing out like small, I'm going to write it all out. But we're going to have 1/3 pi times 1.5 squared times the height is 15. And then minus the little cone was 1/3 pi radius 1 squared times 10. And you just type this all in the calculator. It's going to round to 24.9 cubic inches, okay, if we round. All right, so you just type this whole string in. I'll be the last thing I show. I'll just type in 1/3 pi and then minus pi. 1 squared is 1, but then times 10. So I could just type this in like this. And so we get 24.87, which rounds to 24.9, which is the answer to the last one. And that is the last question here. Wow, almost 6,000 people stopped by. Thank you all so much for being here. And yeah, you get partial credit. Like, let's say here I had stopped at this part. I would get some like nice partial credit here. So it's yeah, there's the same thing with the proof. Like, this question is a nightmare to grade. Like, no one likes grading these. It's just like, ugh. So if like you get like most of it, it's like, hey, 4 out of 6, not bad. So, just do your best. I'm rooting for all of you, and I'm proud of you all for being here. This takes a lot. There are a lot of people who like say, no thanks, I'm not going to try. I'm just going to show up and guess. But like, hey, like, you all being here and studying and getting ready for this thing and being stressed. I appreciate you all, and thank you so much for being a part of the 2025 review. Yeah, thank you for that. I had fun doing 2.5 hours of math with all of you, or 2 hours and 24 minutes. But thanks. All right, and good luck tomorrow. Being nervous is part of it. All right, so if you wake up nervous or you're nervous right now, like it's totally normal. But there's a great quote from the past, and I'll use your language. There's a guy who said like, hey, being afraid is like fire. He's like, you could either cook with it or it could just burn everything down. All right. So hopefully tomorrow you will show up and you will do the cooking. Okay. So hang in there and good luck. And yep, I'm out. So take care, everybody.